That's your turn. Hi. So my goal is simple. I want to motivate Swift's result type. Some of you have built your own result type, but it's coming into Swift 5. Warning, we're not going to get to result for quite a long time, because I want to talk about some of the things that happen when things go wrong in your Swift code. And let's look at examples from the Swift standard libraries. For example, when you try to access elements in an array. So I'm going to start with an array of the vowels, and let's pick one of them out. I'm going to pick out vowels at position 1, and I get the letter E, and I just feel so good about myself. So now let's pick out vowels 10, and they could have implemented it many ways. They could have just wrapped, you could have just done mod and come around again and picked it out. They could have given you a nil, but arrays act pretty much the same in many languages. If you ask for something that's beyond the end, you tend to get a fatal error. And so that's the way element access is in arrays. None of us are surprised, and we don't really think much about it, even when we compare it with element access in dictionaries, which it's really different. So here's a very similar dictionary. I'm using integers as the index, as the key, and the vowels as the values. And so this time, in these key value pairs, when I ask for vowel 1, I get E. And when I ask for vowels 10, I get nil, which tells me there's an error in my playground, and that wasn't really an E. Instead, that was an optional E. So for arrays, we got fatal errors. For dictionaries, we used optionals. Let's look at a third approach using URL session. So I'm going to create a URL from a string. And yes, I know that would in fact be an optional, but I'm going to ignore that part, so let's force unwrap that because, that's good coding. But now that I've got my URL, I'm going to create my data task, my URL session with that URL. And once I do that and I send it out into the world by telling it to resume, I will get a callback. And that callback will include the data, the response, and an error. For now, all I care about is the error, because I want to point out this is our third way of handling things. If we get an error back, we can check what it is and do something. Now, we're all coders, so we know we print the error and then we just go on with our life. Otherwise, we treat things well. So a URL session, we're handling the returned errors. An array, we're getting a fatal error. A dictionary, we're getting optionals. So let's create our own. And my example is simple. I'm going to use a function called doubled, and it's going to double the numbers between 0 and 10. So if you give me a number between 0 and 10, I'll return you twice it. If you give me a number outside the range, we're going to have to deal with something. And let's start by issuing a fatal error. So here's my function doubled. It takes an int, it returns an int, and so I'll make sure that I'm in range, that if I'm negative or I'm bigger than 10, then something's going wrong, and I'll issue a fatal error, and I'll just tell you that I'm out of range. Now, if I'm in range, if I'm between 1 and 10, then I'm going to go ahead and just double the number and return that. So you call doubled 5. Anybody got the answer? See, I knew you could do it. Double 20, fatal error. So the program crashes. What's the big deal? That's one way of handling it. And if it's something important where we do need the program to crash because it's in a state, either development or even when we've shipped it out to people, then maybe it's important that it's in a state where we need to crash it. So imagine I have another function called +1. +1 takes an int and returns an int. It just takes the int you give it and adds it 1. And what I'd like to do is double a number and then add 1 to it. And so if I double 5 and then I add 1 to it, it's the same hands. And so I get 11, and if I double 20 and I +1, I get a fatal error. I crash before I get to the +1. And so it acts pretty much the way we expect. I can even use doubled twice. I can doubled the doubled, and if I doubled the doubled 3, I get 12. And if I doubled the doubled 10, the first one works fine, but the second one I'm trying to double 20, and I get my fatal error. And just as a picture to set us up, the idea is this: if I start with doubled, and I chain +1, then doubled followed by +1. Where do you get graphics like that? If the doubled works, the +1 is definitely going to work, and if the doubled instead fails, then I don't ever get to the +1, I've got problems. So doubled followed by doubled, doubled followed by +1. So doubled followed by doubled. Now I got different places this can go wrong. If the first doubled works, then either the second doubled works or it doesn't. If it doesn't work, everything blows up. If the first doubled fails, then everything blows up. So fatal errors don't make me so happy, but let's look at chaining these together. You forget sometime how unusual you are, and I don't mean that in a good way. You look at code like this and it feels natural to you. You read from the inside out, but that's not how normal people read. Normal people have trouble parsing this. I mean, you can get 15, but what we might do instead is we might introduce an operator. And so instead of writing doubled 5, I'm going to write 5 piped into doubled. And that doesn't look like such a big deal here, but it allows me to pull this expression apart and look at it piece by piece, where I take the 3 and I double it, I add 1, I double that, I add 1, and this looks more natural. I can start with the 5 and run it through the chain, and at some point I'm doubling 11 and I'm out of range, but I saw where things went bad. I don't have to go to the +1. And so fatal errors coupled with this operator, we can see what's going on. Fatal error is one way to handle things. The other way we would tend to do things is with an assert or a precondition, and that just makes the typing look nicer. The syntax is a little nicer because this if conditional gets bundled up into an assert, and we assert that something is true, so we've turned the logic around. And if it's true, I'll return the result, and if it's not true, I'll print out the error message. So fatal errors, asserts work about the same. They're kind of like durian, right? When it's good, it's not bad. But when things go wrong, we crash when we hit our first problem, and we're pretty much done with things. So maybe we want to look at other ways of handling errors, and one of them is optionals. And it's interesting because this is very natural to us, but we don't think about this as the way we handle errors, but this is how we handle when things go wrong all the time in Swift. And so now my function doubled has to change. Instead of returning an int, it's returning an optional. And so I'll switch on my input, and if it's in range, if it's between excuse me, 1 and 10, then I'll return my doubled of the input. And otherwise, as my default, if anything goes wrong, I'll return nil. So that's a way of handling if I'm out of range. And this time when I take 5 and I double it, I get the optional 10. So I get my answer, but it's wrapped up inside of an optional. And when I get 20 and I double it, it's nil. And the really nice takeaway here is it's not an error. Things didn't crash. I go on with my life. There are, of course, problems, or our talk would be done. And that is if I double something and now I try to pipe it into +1, I have an error. And the error is that doubled is giving me back an optional, but +1 is still waiting for an int. And so +1 says these types don't match for me. I can't match up this way. And so what we've done is we've taken doubled and we've tipped it. And we've tipped it so it goes from int to optional int. And so when we try to pipe that to +1, we've got a problem. The output of doubled doesn't match the input of +1. And you say, but this is a pattern I know. This is a pattern I love. I went to your workshop the other day and I know what this is crying for. This is crying for map. And this is exactly what map does. I have a function from int to int, but you don't give me an int, you give me an optional int, and so I have to lift this up into the map of +1. And when I lift this up to the map of +1, now I'm up in the world of optionals, and now this works as we want, And so now I can take 5, double it. That's an optional. So I can't put that optional into +1 because the types don't match up, but I can put it into the map of +1. At this point, I'm a little concerned because you can read this slide, and so I introduced yet another operator. This is the map operator, and now we write it like this. Now, I've chosen these operators because these seem to be what the Swift community is standardizing around. In the early days when you got your little JSON libraries, everyone used their own operators, and now we seem to be standardizing on the pipe forward for the apply, for plugging 5 into doubled, and this, I don't know what you call it, for the map operator. And so I can take 20 and doubled it, and I get nil, and map on optionals takes nil to nil. It doesn't ever plug it into the +1, and so using the map operator here is wonderful, and I'm so excited until I get to this slide, and I say, well, what if instead of sending doubled into +1, I send doubled into doubled? And that's an error, as you expect. And you say, but Daniel, we just learned map. Why don't we map it? It's still an error. Doubled goes from int to optional int, and so doubled into doubled, they again don't match up, and so you say, well, I'm going to use map, and now you've got an optional optional. And that's why we have flatMap, so that we don't keep going up into the wrapping it and wrapping it and wrapping it world. And so flatMap, instead of mapping it where we'll get an optional 12, so that's map, we could flat map it, and now we get rid of one layer of optionals, and we just have optional 12. So handling errors is kind of nice with this optional once we embrace the map and the flat map, but Daniel, we need a special operator for this. Okay. There you go. This is so fun with new team members. So if I take 6 and I double it, and then I double it again, I get nil. So I either can get nil from the second doubled, or here I get nil because the first doubled is out of range. And so the nice thing is optionals chain nicely. I get nil when I hit my first problem. The problem is I don't know what that problem is. I just have nil. I don't know if it was because it was too small, too big. I don't know what went wrong. And that's why Swift has errors. So the error type is going to allow us to figure out what went wrong. So for my error type, I'm going to have this input out of bounds error. All you have to really do to be an error type is conform to the error protocol, which is just a marker protocol. I love to have errors as enums. You can use structs, you can use other things. In this case, I'm going to have two cases, negative number, or the number is too large, it's bigger than 10, in which case I'm going to say, well, how much too large was it? So let's fix doubled. Doubled is now not returning an optional. It's not returning an int. It is either throwing an error or returning an int. And of course in Swift we don't have typed errors, so I don't know what error it's throwing, but we move on. So case 1, I check to make sure that I'm at least a positive number. If I'm not a positive number, I'm going to throw a negative number error. And then I make sure that I'm no bigger than 10. If I'm bigger than 10, I'm going to throw a number is too large error and tell you by how much it's too large. And if I'm in that right range, I'm just going to return twice the number. So I'm either going to throw an error or I'm going to return an int. And that's confusing, because what does the next function in line do with that? Sometimes you get an int, sometimes you throw an error. So it's not this int to int, it's this int to int, and sometimes you throw an error. Or a scuba diver. I thought it was a parachuter until I looked at it. So how do you handle something that's giving you two different, completely different types? It's an int or it's just error. You do it with a try. And when you do it inside a try, now you have to decide, okay, I've tried, I've resolved that error, what am I going to return from that function that is doing the trying? So maybe I have this doubled if can method, and that's where I'm going to do my try catch, and I'm going to return an int. So when I call doubled, I do that with a do and a try, and inside of the catch block, I print the error. And that feels pretty good, except my promise is I'm always going to return an int. So even in the catch block, I'm now stuck having to return an int. So you think, well, maybe I'll use an error code like -1. So I take 5 and I double it if I can, and I get 10. That looks good. I take -5 and I double it if I can. There's my error code, and it prints out error, negative number. There's 20, I double it if I can. I can't, it's too big. I get my error code, and I'm feeling good until I try to pipe that into +1. I take 5 and I double it. I get 10, I pipe that into +1, I get 11. I take -5 and I double it, and I got -1 as my error code. It's an error negative number. I plug that into +1. I still have my error code, but that -1, I've now added 1 to it, and my value is 0, and tried debugging that. Oh, why don't we combine them? Why don't we use an error and an optional? That'll be better. So instead of returning an int, I'll return an optional int, and so instead of this error code of -1, I'll return nil. That feels a little better to me. I can use my map operator, and I can get my optional 11, and I can get my nil, and use my map operator, and get my nil with the... So this is feeling a little better to me, this error with optional, but I had to do it inside this try catch, and I had to make this other decision. And even though I love that I know what went wrong, I am forced to deal with what went wrong right away. I can't wait. I have to do it when I call that doubled method. And so I have to deal with what went wrong now. So, what we want are little bits of these things. What we want is a combination somehow of what we had with optionals and what we had with error types. And so I want one return type, whether success or failure. So I can't use errors. Optionals gave me that, but errors gave me that int or it threw an error. I would like to also have a record of at least the first error. The error type gave me that, but the optionals didn't. And I want the ability to keep going if there are no errors. So I don't want to just crash the program with a fatal error or an assert. And so I want this hybrid of optionals and errors, and many of us have written our own for years, but it's now part of the Swift 5 standard library, and that's the result type. No, we're going to actually do it now. So here's the result type in Swift 5. The result type looks horrible because there's a generic there. Don't panic. It's really generic in two things. It's generic in success. So in our case with doubled, it's going to be generic in int because it's going to produce an int wrapped up in a result if everything went well. And if things didn't go well, I need some sort of an error that I'm going to wrap up. And these are bundled in the result, so my function is always returning the same type. And so some people have done their own result type, and it looks kind of like this. They just use Swift's error type for the failure, and so they only make it generic in success. And if there's a failure, they might even call that second case the error case. They'll bundle up just an error type. But in Swift 5, our result type is generic in both, and the failure conforms to error, which is something that couldn't be done before. The Swift team actually jumped through some hoops to make that happen. It's implemented as an enum. There are two cases. There's success. Success is this success value type, which is int in our case. And there's failure. Failure in our case is our something that conforms to error, and that's going to be the one that tells us whether we have a negative number or a number that's too large. And so doubled will now look like this. Doubled will return the result type, and it will either have the int or we'll have the input out of bounds error. And so what can go wrong? I could be a negative number, so if I'm at least positive, I'm happy. If I'm not positive, then I'm going to take that negative number error that I had before, I'm going to wrap it up in a result, and I'm returning a result type. So from everything that happens, I'm returning the same type. And if the number is bigger than 10, I'm in trouble, so I'm checking that the number is no bigger than 10. If that fails, I'm going to take my number is too large error, calculate how much over it is, wrap that up in a result type, and return that. And if I'm successful, and this is the part that looks a little funny, I don't just return 2 times the input because that's just an int. I still have to wrap that up into a result type too. So if you've dealt with a lot of optionals, you've had sort of this pain where you have to unwrap something. You go, oh my gosh, just give me the answer. And you can't because you had the option that it might have been nil, so you have to deal with the fact that it's wrapped up. So all of these cases return a result type, either of these 2 failures or success. So I take 5 and I double it and I get a success of 10. I feel great. I take -5 and I doubled it and I get a failure negative number. These are all result types. I get a 20 and I doubled it and I get a failure, the number's too large, it's 10 too big. And now I try to push that result into my +1. And I've got that same problem that the types don't match. I've got this result type coming out of doubled, and the +1 needs an int, and by now you say, well, then we need a map. And we do. So let's create the map for result type, and for inspiration, let's look at other maps that you know and love. Here's the map for arrays. If you have an array and you want to apply +1 to it, you don't apply +1 to an array, you apply the map of +1, and it adds 1 to every element of the array. If instead you have an optional, you can't +1 an optional because the +1 is waiting for an int, so we map the +1, and the optional 5 gets mapped to an optional 6. And using that same map, nil gets mapped to nil. So for result type, my 2 cases are success and failure, and so I would hope if I have success of 10, that the map of +1 will give me success of 11. It will reach inside, it will +1 that value, and then it will wrap it back up in a success. And if I have a failure, which is smaller not because I'm embarrassed, but because it has to fit on the slide, and I +1 my failure, then what the map of +1 is going to do is it's going to say, you've already failed, I can't add 1 to you, I'm just going to continue to tell you what that failure was so you know the first place it failed. So let's write our map. One of the nice things about map after you've written 1 or 2 is the signature is always the same. It's a design pattern. It is always generic in the output type. It always accepts a single function. The single function says I'm going to map the input type success to the output type success. And what it's going to get out of this map is a result of that new success type. So that's what map looks like for result, and I'm going to get it by switching because it's an enum, it's either success or failure, and so if I switch on self, the success case says, okay, look inside of success at the value. It was success of 10. Hold on to that 10, assign it to the variable named success, and we do that with that let binding there, and now use that function that maps a success to a new success, and wrap that back up into success. That's what we're returning. So a result of type success has been transformed into a result of type new success. And in the case of failure, again, I hold on to what that failure was because, you know, that's how I was raised. Once I've held on to that failure, I wrap it in that result type and I return it, and now this map has transformed one kind of result type to another, and now everything matches. I've taken care of this mismatch here, and so I don't pipe forward. Instead of, I use the map of +1, and this is result types map. Use the same symbol for all maps. And so if I take 5 and I double it, and then I map it into +1, 5 doubled is a success of 10, and so mapping it into +1 is a success of 11. -5 doubled is a failure. It's a negative number, so when I map that into +1, it is still a failure, but it's a result type failure. Nothing's crashed, nothing to try catch. I can pipe as many of these as you like. And so take a 20, that's too large, pipe that into +1, it's still too large. And so that was doubled, piped into +1, and now we go back and say, what happens if we take doubled and we pipe it into doubled? And it's that problem of double wrapping it. As you do doubled into doubled, you're going to get a success of success. You think, well, I'm twice as successful, that's great. Until you have to reach inside, because you have to reach inside 2 levels. So instead of map, you replace that map with flatMap, and now you get just a single success. So how do we change map to flatMap? Well, first we change the name. And then we look at the signature, and flat maps always look the same. They don't have a transform from success, excuse me, to new success. They always transform to the new type, result of new success failure. And how do I recognize it? The return of the inner function, the return of that transform, always matches the return of flat map. Whereas map, it would just be, the transform would be from success to new success. For flat map, it's success to a result, generic and new success, and failure. So you have to change the signature, and I wish this was harder, but the only other thing you have to change is in this line here, because transform of success is already the type you want. If you wrap it in success, you've double wrapped it, so just get rid of that outer wrapper. The transform of success is already the type that you want to return. So if you replace map with flat map, you get the success that you want. And so we've built this thing that is a hybrid of optionals and errors. We've used it like optionals, but we've got the power of errors. We know what went wrong, and we can pull that error out at any time that we need it. That is exactly Swift5's result type. The idea was we have one return type, whether we succeeded or failed. We get a record of our first error, and we are able to keep going if there are no errors. You're able to chain results, and the way you can think of map and flat map, one way I think of flat map is if I need recursion, I'm often reaching for flat map because that's what's pushing it up a level. The other way to think of it is if you've got things that can't fail, then we're probably using map, and if you've got things that can fail, you probably have to flat map into it. If you download the latest tool chains, and in Xcode you choose it, result type is already there for you. Thank you.
Thank you, Daniel. We have some questions, although the first one might have already been answered. Are you a Swift contributor and giving us spoilers?
No, I'm not that smart.
Do you love dim sum?
I do. Did anybody listen to my talk? Is the next one, do I like durian?
No, sadly not. Optional value inside result case such as, what about optional values inside the result cases?
Well, I mean, you can get as nuts as you want, but remember, so the person gave me some code, remember that the thing inside of the failure must conform to error, not to optional error. And so you've got to conform to error.
Is this inspired by common web service practices where we return the data as success status or error details?
No, because if you think of that, it's not inspired by that. You'll find this is inspired by the either type in Haskell, which also, and optional was inspired by the maybe type in Haskell, and so you'll hear other functional language talk about the optional as a maybe. People, excuse me, the discussion on the list were, do we need this? Should we just have an either type? Either type has a left branch or a right branch. What they liked about this is they're being definitive in saying it's a success or a failure branch. And so it tells you the actual use case. The either type is a little more general than that. The other thing that came up in the discussions, I don't know how many of you are on the Swift evolution list, but if you've been reading, people have wanted the result type for years. And in fact, Apple shipped a result type in some of their server code a couple years ago. Apple pushed back, or the Swift core team pushed back, because some of this might go away when they introduce the asynchronous solution. And so a lot of this is wanted when you're dealing with futures and asynchronous, and so that you don't have to make decisions when things come back. And so they even mentioned that in this, that when they do async, and one of the models they're looking at is the C# async await, and Chris Latner has a whole proposal on that, this might become moot.
This guy just came up. The question about the operator wasn't answered. Will these be part of Swift 5?
They're not. And it would be nice if they would standardize on them. It's like the result type. If so many of the community are using these, could you just introduce them so that we're all using the same vocabulary? And that they aren't. So the question was, like the pipe forward operator, why aren't those part of the standard library? And it would be nice.
If handle error with Swift in our error, like Objective-C NS error pointer.
I don't understand the question.
Sorry. It jumped. Oh. Yeah. Oh, there is a question on durian. Dim sum or durian? Oh, and a request to show the slide again from map versus flatMap. You can grab the slides from Slack channel later, I think, because we'll be sharing it over the Slack channel.
I had no idea. I guess they'll be available.
Yes. I think that's about it, if I didn't miss anything. Yeah,
well,
thank you,
Thank
Daniel.
you.
If anything else, you can ask him over Slack.